right, you guys? So we cannot assume we have normal distribution. We need to check if we don't know. Like you can check with the data. So here's an example of unemployment rate in different states from North Dakota, which has the lowest, to Michigan, which has the highest unemployment rate. And we're going to plot the data. So yes, I want you to enter this in your calculator. If it's not perfect, don't freak out, but let's get it as close as we can just to practice this. So go to your lists and spreadsheets and enter all of the data. All right, you guys, so the first way to check is by making a graph. So if you guys would just make a quick histogram, remember you can go to Control plus a page, Control Doc, adds a page, and then you add your data and statistics or add a graph or whatever it is. Yeah, add data and statistics. At the bottom, put whatever you titled it, unemployment, and then go menu, and it changes. Nah, no. So menu, plot type, histogram. All right. All right, you guys, so by looking at the shape of the graph, would you guys say roughly symmetric? Yes, I would as well. Okay. So one thing we can do is actually check the 68, 95, 99.7 rule, right? Now, if I was going to check this, what two important things do I need to find that are not necessarily on my graph in order to actually check this? The mean and the standard deviation, right? I'd have to find the mean, and I'd have to find the standard deviation. So hopefully you guys remember how to do that. So everybody go back to your spreadsheet. And you can do it in this section here. Press menu, statistics, stat calculations, one variable statistics, put unemployment in there. And we get our mean of 8.7. And our standard deviation, 2.2. So 68% of the data would have to fall between, what would be the lower bound for 68% of the data, you guys? .5, right? We do this minus a standard deviation. And what would be the upper bound? 10.9, okay? And then we do 95% of the data where we'd subtract this again. So 6.5 minus 2.2 gives me 4.3. And we'd go to adding 2.2, 13.1. So what percent of the data falls in that range? Okay. And then 99.7% of the data, we subtract another standard deviation. So minus 2.2 would be 2.1. Added 2.2 would be 15.3. And you would count all the numbers, right? We did this the other day with the dots, so I'm not going to go back over this. But you would see how accurate that was. Does that make sense? For one way to check. And will it be perfect? No. But if it's close to those percentages, you're good to go. All right? However, this is a much faster way to check. I don't like counting all the numbers, counting all the dots, especially when you have 50 numbers, right? So here's the way that you should do this on your calculator. So everybody go to your calculator, go back to your histogram. Okay, so get back to your histogram. And go to menu, and go to plot type, and go to what's called the normal probability plot. I tell you guys that. And you get the data points traced against the z-scores. The more linear it is, the more normal it is. So is this data normal? Yeah. It is fairly linear, okay? So anytime it's approximately falls on that straight line, so you just make a normal probability plot. If it's close to a straight line, the data are approximately normally distributed. And then anytime it deviates, we could have some skewed graphs. And if there's an outlier, it's going to be really far from the line. If you get data that looks like this, so it's very curved to the right, this guy is skewed right. The way that I remember is if you were trying to line them all up like that, it kind of falls off to the right. And if you have data that curves the other direction, then it is skewed left. And therefore, it's not normal, you guys. So you can't do any normal stuff, which is what we do most of our things on based on the fact that it's normal. Okay? So you can graph these, make a normal probability plot. It can just be a sketch. Do label your axes with unemployment rate and z-scores. That's what, so they know you know what it is. And then you can say it's normally distributed based on this normal probability plot, which gives me a fairly straight line. So here's an example of something you might see. We introduced the data on survival times in days of 72 guinea pigs after they were injected with an infectious bacteria. Sorry. Determine whether these data are approximately normally distributed. Okay, so by looking at the histogram and the normal probability plot, would you say that the guinea pig death rate is normally distributed? No. No, it's skewed right. Look at the graph, skewed right. And this is not linear, it curves to the right. And so you would say no. Okay? That's it.